Hello, good evening and buonasera. Today I'm sitting together with Luca Mezzalira and we will talk about micro frontends and his second edition, his brand new second edition of his book on this topic. Hi, Luca.
Hi, Manfred. How you doing?
Cannot complain, and you?
Yeah, all good, all good. I can't wait, honestly, to have this discussion with you because honestly, I highly respect you in the technical side, and I think we are going to have like a nice chat together about micro frontends.
Awesome, awesome. Yeah, so I just mentioned before when we chatted a bit, your book is somehow the industry standard for micro frontends. And I think it's one of those books. Not many people achieve this, but it's one of the books that will be relevant even in years, perhaps in decades, because, yeah, it describes everything that nicely in a way that is everlasting. It's a, how do we call it, a evergreen topic, isn't it?
Thank you very much, Manfred. To be honest with you, I was surprised as well about the success of the book, especially the first edition. When I spoke with O'Reilly, they were telling me that they had a very interesting pattern of my book, hence why they asked me to write the second one, because they started to see, let's say, good, let's say, amount of people that were interested at the beginning, but then it started to ramp up even further 2 3 years after the book were released, and because of that they told me, listen, do you have something new to say on my front end? Listen, I got like basically brand new book, and hence why I spent like the last 18 months, 20 months writing the new book, and then it was released in November, if I remember correctly, 2025.
Hmm. Hmm. Cool. So it seems like you have been an early adopter, and perhaps that's why people slowly started buying it more and more over the years.
Yeah, correct. I think there was a boom of micro frontends implementation and penetration in companies, especially enterprise customers, probably around 2020.
Mhm.
2022, more or less. That 2 years, basically, I started to see a surge of requests around micro frontends, especially because I believe people start to understand that they struggle a lot on the delivery side. They moved many enterprises when they have like I don't know, 50 hundreds or more developers. They had like a clear pattern on the back end leveraging microservices, while on the front end they didn't have, let's say, too many options apart from
Mm.
trying to be as polished as possible in their code base. But we both know that in the long run, when you have, let's say, multiple people that don't have, let's say, clear ownership, and they jump from different areas of the applications, that they need to have a lot of cognitive load that is thrown at them because they need to understand every single line of code in large application. That is
Mhm.
not sustainable, and it doesn't result in something that is, let's say, easy to maintain. And therefore, this idea of leveraging the principle of microservices, splitting up an application into modular chunks that can be deployable independently and owned by a single team, it started to have a lot of legs.
Mhm.
Despite the JavaScript community at the beginning was a bit skeptical when I started to pitch certain ideas behind that, but obviously distributed systems are by far different from monolithic ones.
Yeah, yeah, totally. Suddenly you have to embrace pattern you did not need before, perhaps pattern that have been considered an anti-pattern before. And it might also increase the complexity if you use it and don't need it. Have you also seen such situations where people used it while they did not need it?
Yeah, unfortunately, it's quite common, right? Because the thing is, we live sometimes with hype, and
Mhm.
the main problem with micro front ends is that they can become very complicated very quickly if you don't know how to tackle them. So if you treat them like components, obviously you are already a step closer to fail miserably your migration to micro front ends, and that's probably I would say is the main problem that I have seen in the last, I would say, decade with micro frontends, when they went too granular too fast. and you don't create the governance around, you don't provide, let's say, a decent, a decent time on invested into the designing the system, that I think is the most important things. And to be frank, it's not only for Frontends, it's for any system out there. If you, even with microservices, if you just rush to create the nano services, you're going to have a very tangled system in no time. And that's the challenge or the drawback of distributed systems.
So how did you become an early adopter on this topic? I think you already did it before it was a hype, a fashion.
Way before. So I started to, even before the name Frontends, because, by the way, this is the 10th anniversary of the name Frontends that came out in 2016. So as you can imagine, super excited. But I started in 2015 thinking about how can I overcome a specific problem in the company I was working for that is called The Zone. This is a live sports streaming platform. The problem we had is that we need to handle roughly 30, 40 different devices, like living room devices specifically, and set-top boxes, for, let's say, quick update of the application. And some of them were quite controversial because you can, not every single device has an app store like you have on mobile. And even then, if you have the app store, it doesn't mean that the penetration of a new version could, let's say, be immediate. So what happened back in the days, they asked me to figure out a solution that will enable us to avoid the common issue of certain set-top boxes that have a lot of penetration inside the market, but they are quite old, where I can only update my application flashing the firmware 2 or 3 or 4 times per year. So as you can imagine, in the life cycle of an application, deploying 3-4 times per year is not ideal. So therefore, that I've seen later on also apply to from Netflix, we had this idea of decoupling basically the container of the application by the application itself. That back in the days, we were doing exactly the same thing on my in another company I worked for on gambling and for mobile application. And even when I was a Flash developer, one of the technique for making the application extremely responsive and light was creating an empty movie clip that basically enables you to lazy load a Swift file inside the Flash application. That enabled me to work also on embedded system with Flash, despite people were saying Flash was rubbish and performance-wise wasn't working properly. But I ran inside a Centrino board, the first Centrino board we had in Europe, dual core Intel, where we put inside a Ducati motorbike, and we basically power the dashboard of the motorbike with a Gen 2 application, Gen 2 operating system that was running a C daemon that retrieving the data from the, let's say, motorbike, like the engine directly, so the speed, RPM, etc. And we were basically displaying in tens of milliseconds directly on the display that we were using. It was like a fantastic project, but in general, the idea was coming from that, and worked pretty well on mobile on TV devices as well, because first of all, we have seen a boost of performance straight away, because we were just loading the JavaScript was needed compared to the single page application we had at the beginning. Also because on let's say living room devices, you have to bear in mind are low end devices. There are, let's say, for instance, an iPhone 12 probably has more power than any other set-top box out there, without taking into account, obviously, Apple TV or specific Android TV application where the hardware is really, really good. So for me, starting with this idea of lazy loading applications and then trying to understand how to split them was mandatory back in the days, and made a huge impact in the industry, because when in 2017 I started to preach this idea of we have done this and this is how we have done it. I remember the first conference I did like a talk of 40 minutes in Ireland. And then I spent roughly 5 hours answering questions outside the stage. and that happened again in Amsterdam with a colleague of mine, where we deliver a similar talk. And the thing that people didn't understand how was possible and how to do that, because again, it wasn't a framework-based approach. It was an architecture design approach that I was quite familiar with, because in the past I designed a lot of architectures for frontend, but not only. And therefore, for me, it was like day to day. But I understand very quickly that for many people, it was, let's say, out of their comfort zone, because they were used to do, especially in JavaScript, taking a framework and leaning towards the best practices provided by the framework itself. While in this case, we need to detach from the framework itself and start to think holistically, how can I create a system that let's say, improve our organization? Because at the end of the day, any distributed system is not only for the users out there that will have some benefits, but majority of the time is for the organization itself, that will be able to ship faster and to have, let's say, clear boundaries and ownership across teams. That is not a simple task at the beginning.
What I really like here is that this entire idea was driven by business needs, like bringing the zone to a lot of different environments and splitting it according to different parts in the organization. Another aspect that has to do with this, or that looks at this point of the world, is domain-driven design, something you also mentioned in your book. So how does those two topics come together? Frontends on the one side, micro frontends, and domain-driven design on the other side.
So back in the days, I was responsible for, let's say, thinking about the evolution of the system, because we were growing very fast, and we moved from more or less 50 people across the entire organization to 3,500 in a matter of, let's say, month, like a year and a half, 2 years max. Because we started to put more emphasis into the system. We started to grow from tens of thousands of users to millions of users, and obviously required a completely different mindset on how to structure ourselves. It was crystalline clear we were starting to onboard a lot of teams inside the company. In fact, the tech department was composed by 550 people. That is not a small tech department if you think that we are in Europe and not in US. Spread across, let's say, 4 different cities. And therefore, for me, I had to figure out how can I make it work across with all these, let's say, in this specific situation, social technical situation. And the only thing I was thinking of was, okay, on backend, I have a plan. It's called microservices. I didn't apply it at scale before, but for me, it was crystal clear that was the only way I could enable multiple teams writing the backend and deploy independently, fails gracefully, scale independently, and so on. And therefore, we went in that direction. But from front end, I have the problem that I have equally as many front end teams that has to ship a lot of stuff and multiple devices. And some devices I can share some code, some others I cannot. And therefore, my idea was, okay, let's start from let's take the principle that usually I use when I design microservices. Therefore, I started from domain-driven design, looking into, strategic domain-driven design specifically more than tactically. So because the strategic one enables you to look, take a step back, look holistically on the system on the business side. And I started to look into the capabilities that we have. And slowly but steadily, I recognized some subdomains that were kind of clear inside the system. And then I layer up basically the subdomains that I identified on the paper with the data points that I retrieved from Google Analytics, and see how our users were interacting with the platform. Well, turns out that very quickly I could see, let's say, some patterns that were quite clear for us. On the back end, obviously, they were had to, let's say, be more granular, because we have by far more teams on that side. And we had to split, by the way, not in cross-functional teams as I wished at the beginning, so having front and back end together, but in front-end teams and back-end teams, because the amount of programming languages that we have to build would force us to have, 14 people per team if we wanted to develop a specific feature across all the devices, because we were using Swift, we were using Java for the Kotlin specifically for the Android applications. We were using for web React and MobX. For some TVs, we were using React and MobX as well. Some others, we were using custom languages dedicated for that. So it was fairly complicated scenario. Therefore, we couldn't afford to have, let's say, a single team of write JavaScript for everything. Otherwise, the performance will be jeopardized. We even have 2 teams dedicated to the video players, because the video players were extremely complicated. Even we evaluated that. You have no idea how many, but the complexity is that at the end we ended up building our own live streaming video player, because all the ones available, even open source, weren't reaching the level we wanted. But going back into the how to split the application, for me, it was crystal clear that there were some patterns that were mapping in a more coarse-grained fashion compared to the backend into the front end. So we had like a lot of landing pages, a lot of traffic there, millions of visits per day back in the days, where basically I had to create a custom, let's say, implementation. So using ISR, so I can render at build time everything, store inside the CDN, forget about it, and I know that million of requests won't hit origin or would not affect all my APIs, because they are very well stored with all the data already available into the CDN. Later on, there was a split after the landing page. Either you are an existing user or a non-existing user. If you were an existing user that you have already access to the platform, the landing page was skipped straight away. So you went straight to the catalog. That means basically you save a lot of kilobytes of JavaScript weren't loaded because you basically don't have all the payment SDK integrated. You didn't have all the landing page, all the logic for sign in, sign up, all the different integration we had at that stage. So you basically load the catalog and you load the video player. That was it. You didn't, because at the end of the day, the rest of the system wasn't needed as much as the catalog when you were, let's say, an existing user. Obviously, you could also navigate into the My Account page, but I basically count like probably a single-digit amount of users that were going there. So I split them up in a different mic front end. And then if you weren't an authenticated user, you were a new user or an existing user that was moving in another device. In that case, I basically started to map the onboarding journey, where you have sign in, sign up at the beginning together. But slowly but sadly, when we started to roll out new countries, it turned out that it was impossible to keep the cognitive load of all the different payment methods for new users and in new countries, because every country has its own, let's say, set of payment methods based on the partnership that we had. Therefore, we split them up into 2 teams, one dedicated on sign-in only, retrieve email, retrieve password, and the other one dedicated on payments only. And the beauty of that is leveraging domain-driven design. I could map and design things on how the backend was communicating together using synchronous and asynchronous programming on the backend. At the same time, on the front end, I was able to map a single micro front end to a set of microservices. So therefore, my design became, let's say, very modular with a coarse-grained granularity. We didn't go straight like the classic mistake that I've seen very often with teams is, we treat microfrontends as components, so at that level of granularity. That failed miserably very often, because you are basically, let's say, confusing a component with the microfrontends, where in a component, the domain is owned by the container of the component. If you think about a button or if you think about, let's say, a carousel, whatever it is, those components are basically providing, let's say, an easy way to integrate a specific feature that is consistent across the entire application. So what you are basically building them is for reusability. While for a micro front-end, instead, we want to leverage the capability of independent deployment and reducing the complexity for teams that are completely or almost completely independent for deploying new version. Therefore, we cannot leverage the same approach. We need to be more coarse-grained and encapsulate the business logic inside that. If you start to think in this way, now suddenly the having fine grain components that are lazy loaded create, let's say, a complexity that basically makes impossible to maintain over long term. So what I usually do with every single team that starts with my front end, I start to use what I call the vertical split. So I take one page or group of pages and assign to a specific team. We can always tweak them and split them further or aggregate later on. It doesn't really matter at the beginning if let's say you find the perfect boundaries. The important thing is that you start to move towards this paradigm and you start to learn how it works. And that for us in the zone was the first thing we started with, for instance, with the catalog, and then we moved into the landing page, and then sign in, sign up, and then all the rest. And slowly but steadily, we were deploying the new mic front end when we had the possibility and the mic front end was ready. At the beginning, was living alongside the let's say the application, the existing monolith application, and then slowly but steadily we were migrating towards the new approach. But remember, back in the days 10 years ago, we didn't have, let's say, a book. We didn't have, let's say, reference. It was literally a lot of banging our head on the wall and trial and errors and trying to figure out what made the most sense. For me, it was a very interesting challenge because I had to take basically the principle of microservices and then tweak them towards front end in a way that makes sense for front end. And therefore, it took like a while before we reached, let's say, the right trade-off for making that working across all the different devices that we were supporting.
Yeah, you really speak from my heart. One thing I really find interesting here is that you at least say it between the lines that achieving a perfect slicing is really hard, and perhaps there is not even a perfect slicing. So you somehow need to get going, and then you need to adjust your path on the go.
Absolutely. The challenge overall in boundaries, and that is not only for micro frontends, is in general for everything. Even if you think about in a monolith, you want to define the boundaries for a module. How coarse grain or fine grain should it be? So it's not, let's say, an easy approach. Therefore, for me, it's an iterative approach where boundaries is the only thing that there are some heuristics that I use nowadays for identifying them in a simpler way. One, for instance, is rate of change is an important one. So how often do I change a specific module? And I usually give this example to explain it. So think about, for instance, you are creating a payment mic frontends, okay, where you have, let's say, multiple payment methods. But then you realize very easily that maybe you have like 4 or 5, but there is one, maybe credit cards, that require more maintenance in the long run, while the rate of change of a PayPal SDK or any other SDK is way lower. So potentially a good way to tackle that, it could be that you create, instead of, let's say, a very complex micro front end that has like one payment methods per micro front end, you can have, let's say, an aggregation of multiple payment methods for one micro front end, and the other one instead, that is the credit card that has a high rate of change, is in another micro front ends. Why that? Because in reality, the rate of change is driving that decision, and it's very likely that those two micro front ends, because they live inside the same subdomains that these payments, will be owned by the same team. Therefore, that team doesn't have to coordinate with the other teams. That's the beauty of this. So when you start to look holistically on the socio-technical system, so how so who is owning what, and how granular I wanna be, I can decide that having these two micro front ends for payment could be good, or I can decide that I want to have a single one, and obviously I will bite the bullet on having, let's say, to retest every single payment methods every time that there is a change. So here we are just discussing about trade-off, and there is no such thing like the optimal trade-off. It's just every single trade-off has some pros and some cons, and therefore, if you start to think about that, you start to see that, there isn't a way that I can tell you, oh, Manfred, 100 lines of code is a micro front end, or 1 million lines of code is a micro front end. It's impossible giving you that. But if you have heuristics like security, or you look into the rate of change, stuff like that, you start to see what should be inside the boundary or outside the boundary, if you can split it, or it's better to be more, let's say, coarse grain and having collocated code there. And similar, it happens also on the back end. I have, like, for instance, a customer that is working on finance. And in finance, for instance, they were telling me, "Oh yeah, we are dealing with the stock market." I said, "Okay, so you need to reduce to the bare minimum the communication over the network, because otherwise, every single hop you are penalized by milliseconds, and you need to be, let's say, very well aware that if there is a change of a stock, you need to update the price." So therefore, the modularization happened not at the infrastructure level, but at the code level through creating modular application that has different modules. Instead, similar to micro frontends, when you think about how you are going to, let's say, collocate or not the code, is an exercise on understanding how many external dependencies you are creating. And that basically leads very nicely on the shared dependencies, right? Because there are certain shared dependencies that are a must-have, like login libraries or design system, stuff like that. But the reality is everything else that is outside a couple of different things, you need to ask yourself like 3, 4, 10 times before you want to externalize something like that, because you are creating an external dependency that at the beginning seems like a smart choice. But again, if you have a high rate of change, then you need to redistribute the changes across all the different microfrontends and retest them. And it's not a walk in the park, because basically you are, for the vanity of creating something reusable, you ended up to create, let's say, a bottleneck further down the line when you are on the testing phase. Every time that you change something, is going to be retested. So it's becoming very complicated very quickly. And that's why the design phase of micro frontends is extremely important.
I think this is really an important topic, and I know that a lot of people are struggling with the question how to slice it. So you just gave us two heuristics, let's call it heuristics.
Yeah.
One was different, I think, performance requirements with the
Yeah.
stock market, and the other one was different requirements towards something else. What was it?
Correct. So the other one was the rate of change of your
Rate
code.
of change,
So
yeah. Mhm.
that I think is the one of the key ones. But again, it could be security as well. So instead of let's say applying security scattered across multiple micro frontends, maybe you want to centralize one in one place, so it becomes easier. So if I need to change, I change once for everything. So these kind of heuristics that you will discover sometimes before the development, sometimes after, because maybe there is a new regulation is coming in and you need to do something about that, and you cannot just ignore it. Therefore, we need to accept the fact that boundaries are things that can mutate over time, and there is no harm on saying that. The only thing is you need to design things, first of all, making sure that you don't create external dependencies between teams, because if you find too many external dependencies, then there is no chance that micro frontends or any distributed system will work.
Cool. And I think before you also mentioned you looked at the customer journey to find out how
Correct.
to slice it, also into analytics to find out what is used together and so on.
Yes, because that for me was important. I had like my let's say context map where we had all the different subdomains and bounded context of my backend part. And sometimes people start. I remember like 5, 6 years ago, there were people say, "Oh, okay, so I have a microservice, therefore I have a microfrontend." I said, "No, there is no need of such thing, because the reality, the decouplement between the front end and back end is still exactly the same of a monolith. It's called API. So you have an API that is decoupling these two words, and therefore you can say, perfect. So these microfrontends consume 3, 4, 5 APIs from different domains potentially. Or you can create a backend for frontend. There are different, let's say, approaches that you can have on the backend for mitigating the aggregation of different domains, because majority of the time, the backend it's more complicated than the front end, not because you want to overcomplicate the backend, but because if you change something on the back end, then the front end that doesn't have to be redeployed. You can, let's say, externalize a lot of stuff on the front end, so the back end can take over and say, okay, so now there is high traffic, therefore behave in this way. You just provide the signal, and the front end basically will behave in different way instead of redeploying, let's say, a new version.
Mm-hmm. Yeah, I think this is also an important learning, that there is not necessarily a one-to-one relationship, as you said,
Yes.
between microservices and micro frontends. So in your case, was it rather one to many, or was it many to many with a backend for frontend in between?
So backend for frontend pattern, I tend to avoid them in terms of, let's say, just saying, okay, use BFF because we use somewhere else. There are specific use cases, in my opinion, that are great for backend for frontend. And it's basically when you want to aggregate multiple subdomains together. And my classic example that I implemented in several companies is my account. So usually in any subscription service or e-commerce, whatever, my account is a composition of payments, user details, and whatever else, like orders, history, whatever it is, based on what you have. So as you can imagine, those three elements that I just mentioned, majority of the time are, because of the complexity, are owned by different teams on the back end. So there are, let's say, three domains with different domain models. It's completely different the way how you design them and implement. On the front end, though, you want to have a single pane of glass where you see everything, right? So you have a view that I can change my payment method, I can update my address, whatever it is. So there are two ways usually to handle that. One is you use a BFF, so a backend for frontend. So you basically, the frontend team, or the team, let's say the people inside the team that are responsible for the frontend are owning a new layer of APIs where they aggregate these APIs. And the beauty of that is if you have, let's say, not many front-end developers and you have like a complex backend, it means that basically you design a single micro front-end that is communicating with the BFF, that is fetching the data and sending the data to the other domains. And the cool thing of this approach is that you need like a small amount of resources on the front end for handling that part, because the aggregation is happening on the back end, on this back end for front end layer, and can be updated by the front end team as many times as they want. If we revert the complexity and we say, no, we want to have, let's say, cross-functional teams where every team owns its own chunk, now the complexities start to arise, because now it means that we need to have, let's say, at least 3 teams that has cross-functional teams that has the let's say user details, payments, and order history for this specific view on top of the others that they need to handle. And we need to understand how to aggregate, how to modify all together, creating a layer of governance that when someone is changing something won't impact the others. So it's completely doable, but now we are shifting the complexity from having, let's say, 2-3 people that are handling the front end through a BFF and aggregated APIs on the back end, to every team is completely independent. They ship whatever they want, but they need to be aware where it's deployed, and they need to be aware what's happening on the other side, because if someone is changing something, suddenly I might need to change my code as well. And that's where that's the let's say the difference between vertical versus horizontal split, where the horizontal split you have multiple micro frontends in the same view, therefore there is a coordination needed. It's usually not, let's say, as much as working in a monolith, but in general you need to communicate to understand, okay, I'm changing this, might impact you or not.
And this exactly leads to another topic I want to discuss with you.
Yeah.
Namely, there is the decision framework you published quite early. I think it was published even before the first version of the book in your blog.
Indeed.
And
Yes.
it gives you a lot of hold when doing decisions towards an architecture for micro frontends. Can you tell us a bit about it?
Yeah, so what I recognized in the implementation I was making in the zone, but as well talking with other people in the community, that there are 4 key aspects that every single micro frontends architecture required to be designed upfront before starting. So I call them the decisions framework, because you have like these 4 decisions. So one is understanding how to split micro frontends. Is it like a page or group of pages assigned to a team? Majority of the time, I recommend to start with that. It's easier. It's like dealing with small single page applications. And even on server-side rendering works very nicely. I have like plenty of examples of e-commerces that are using this approach with the vertical split on with server-side rendering. It's work like charm. Or you can have horizontal split where you have multiple microfrontends in the same view. Now, the complexity on the second case is, let's say, focusing on the governance, who is owning who is responsible for the final result of one page. So if I have like 3 teams and I'm in an e-commerce homepage, who is responsible for that? Someone needs to be responsible and coordinate the other teams a bit. And that is, let's say, provide maximum flexibility. Classic example, if you think about, let's say, the different dashboard in cloud provider are probably made with microfrontends, many of them, because they even, I remember New Relic did, let's say, a talk like, it was like 6-7 years ago, talking about how they leverage microfrontends for the different dashboards. Because in that case, you have in your observability tools, multiple metrics that you care about and are developed by multiple teams. For aggregating them, they created this, let's say, widget approach, leveraging microfrontends that are basically lazy loading these metrics. The second part is how the microfrontends are, let's say, routed, composed and then routed. So those are split in these 2 areas, because I think it's important to understand, am I doing, let's say, on client-side rendering or server-side rendering? At the beginning, I was considering also edge-side includes, and therefore edge rendering, but it turned out that the main technique for doing that was ESI, that is edge-side includes, that is a quite old markup language that was created by Oracle and Akamai. And basically, they wasn't supported, let's say, massively by many CDNs. Only Akamai had the full specs, and then we have Varnish that has like a bit of ASI, but not much more than that. The developer experience was rubbish compared to the rest. And even nowadays, the real, let's say, challenge of doing edge side in composition is that in reality, the data that are living in the microfrontends are fetched from different regions. If you handle in a CDN, you have, let's say, a multitude of point of presences that are composing your front end, but maybe one point of presence in Australia, but your data are in London, and therefore you're not gaining much on performance because of that. So at the end, we in the second edition, I basically described only client-side rendering or server-side rendering, and those 2 have, let's say, quite a lot of implication, obviously, because if you do client-side rendering, you have a subset of the framework that you can do, and server-side rendering similarly, right? And also scalability-wise and how much you need to think about infrastructure completely change when you deal with server-side rendering, because everything has to be rendered on the server, and therefore you need to find the right tools for doing that. You need to think about caching, a different layer in memory, CDN, etc. While when you move into the routing part is how do you route? There are 2 ways to route. There you have a global routing that is everything that is on the first level URL. So mysite.com/catalog first level URL usually is handled by an application shell. So it's basically routing the request from one version to another one. It could be an application shell, it could be a router happening on the edge, or a router happening inside a region in the cloud or on premise, but the logic is the same. So I'm routing, basically saying, hit that cluster or load that microfrontend. That's what I'm looking for. And then a local routing that basically is happening instead inside the microfrontend. So when I select a /catalog, the microfrontend of catalog is loaded, and it should own the let's say all the other level of the URL, so second level, third level, etc. Because that basically you are handed over to a team or group of teams that are evolving that part independently from the application shell. That is an extremely important part, because you don't want to leak the domain towards the application shell. That is another team basically involved that will impact your release cycle. And the fourth decision is the communication. So how do you communicate? So on horizontal split is easy, because at the end of the day, you can communicate through APIs. So maybe I store some I don't know, preferences from the user. So I basically use the API to store the information permanently, or I can use local storage, or I can use I don't know, query strings, these kind of things. While if I'm in horizontal split, the challenge is majority of the people start with a global state. And because it comes very natural for front-end developers. But the problem they don't understand is that the moment that you have a global state, it means that you are leaking the domain out, the logic outside the micro front-end. Therefore, if I change something, all the others has to be retested. And that's where the complexity lies, because now suddenly people says, oh, micro front-ends are too complex, are not worth it. But the reality is not the micro front-ends are not worth it. It's the implementation that was wrong. So usually what you do is encapsulating the state management inside the micro front-end, while you communicate through three things: either reactive streams, custom events, or my favorite, event emitter. And they are my favorite for a simple reason, because reactive streams, I wrote a book on reactive programming in JavaScript. And let's say that I think it has a lot of legs, but it wasn't all completely embraced by the JavaScript community in general. There were, let's say, a subset of the individuals that they used. Also in Angular, for instance, there is RxJS that is out of the box that I personally love it. But obviously, not everyone had, let's say, the same experience. Custom events are bounded to the DOM hierarchy. So if I have one micro front-end in one node that has to communicate with a micro front-end in completely different branch of the DOM, then suddenly you need to basically find a DOM element that is like common for everyone. That majority of the time is the window object. But the problem is that you potentially have, let's say, another listener in before the window object that can intercept the request and prevent to bubble up. Then basically discovering the bug becomes like impossible. While event emitter solves all these problems, because it's using events that we are used to do with JavaScript very easily, but also is not bounded to the DOM. You can move stuff around without any problem. It's literally just it's based on the observer, not observable, but observer pattern. So where basically what you have is just an array. Every time that you say, okay, I subscribe to this event, you basically, your object is added to the array, and then every time that someone is saying emit, I take this array and I parse it, go through a for cycle and send, okay, I emit this event to this event, and all the events are passing through every single object. Who is interested will pick it up and react. The beauty of this approach is that you decouple completely the system, because it's just an event. I can test in isolation without any problem because it's possible. But most importantly, you have also the possibility to, let's say, plug a new micro front-end without, let's say, communicating with all the other teams, because as long as documented what kind of events are bubbling in a view, I can easily say, perfect, I'm interested on this event, so let me plug it, and I will start to do stuff with my micro front-ends. It's even, for instance, if it fails, no one is listening to an event, there is no penalty in the Chrome console, web console, whatever. It's that literally nothing happened. You just dispatch an event, no one listened to it, fine. You don't have, let's say, stack overflows or any other JavaScript error. It's just literally an event. Those are the four, basically, let's say, four decisions that you need to make at the beginning of every single micro front-ends implementation. And they try that to apply across server-side rendering, client-side rendering, edge-side rendering, and every time those four things bubble up. So for me, that became, let's say, the decision framework.
Cool. So it's also a part of the book, of course. What are the other chapters in the book about?
How many you mentioned?
No, in general, what do the other chapters of the book?
Oh, the other chapter, sorry. So the other chapters, so you have like part of the design. There is also that is the monster chapter, if I remember well, is chapter 4, that basically has a comparison of the most used framework out there, and that try to provide, let's say, and many people really like this approach, a table for, first of all, obviously, I described the framework, how to implement, what are the trade-offs, but then then I created a table for every single framework saying, okay, this one has as a trade-off, I don't know, a low developer experience or a very incredible developer experience on the other side. On this one, you can work only on client-side rendering. On this one, you can work client-side or server-side rendering. So I try to create, let's say, a table for every single framework and library out there to provide, let's say, my take on the trade-off available. On top of that, I added, let's say, a new chapter on migration that is basically talking about how to migrate, what's the mindset, how this common approach that you should use. And also I updated one on the CI/CD because the automation part seems like, that nothing changed. But in reality, there are some tips and tricks that could help to, let's say, having a better micro frontend strategy, especially nowadays with AI. Think about recently we started to hear more often harness engineering approach, where you have like basically sensor and guides, where the guides are basically skills and markdown file, or you have a bunch of other information around, this is my context, and I provide that in terms of prompts or maybe RAG or whatever else you want to provide. And then you have some sensor that usually is on the CI/CD side when basically the code is generated, and you start to say, okay, so I want to have I don't know, the information related to architectural fitness functions. So I want to say this micro frontend shouldn't have any dependency from another micro frontend, but only from the shared library. These kind of things you can implement TSArch, that is a porting of Java Arc unit from Java, that basically enables you to describe architecture characteristics of your micro frontend. If you run them as a test suite alongside your normal unit test and integration test, then you will be able to say, oh, by the way, this is not doable, and you can feed back through the sensor to the LLM or to the code assistance in order to improve that thing and try to avoid happening again. Similarly with static analysis, if you see that it generates code that is not maintainable in general, you want to have, let's say, I don't know, some limits. For instance, I don't know, maximum 10 lines of code per function, or you want to have a certain cyclomatic complexity. These kind of things can be feedback inside your code assistant. So if you have, let's say, at the beginning these guides, and you implement and also some sensors, now we have, let's say, a very interesting and appealing way to, let's say, try to provide as many information as possible and guide the probabilistic system that is the code assistant towards the result that we expect.
Cool. So what do you think, where are micro frontends going to? What is the future of micro frontends? Has it something to do with AI? Will AI influence it? Will something else influence it? Or will there be new developments in this area?
I think definitely AI will have a massive impact on the idea of micro frontends. I think micro frontends fits perfectly with the idea of how we think about, for instance, leveraging components inside code assistant, or in general with AI agents and so on. So if you think about how Claude right now enables you to communicate with that and then generate code. And for instance, I remember the other day I was doing a comparison about different stocks, and I didn't even ask, and he was basically telling me, oh, I created a React application for you, and the render inside the page is to say, okay, as you can see, those are the differences about these two stocks that you're thinking to invest. I said, okay, that is very interesting, because now if I think about that as a micro frontend, I can create or vibe code the let's say behaviors of a specific component, and then I can offer it through MCP inside these tools that will have a certain guidance on how they should render a specific part of the of, let's say, my I don't know, application or whatever I'm building. The other part that I believe will have a very interesting approach with AI is that currently we tend to have AI that is in the middle of the application, or we think, let's say, to have AI always in the middle, like as orchestrator of everything. While instead, in my, let's say, tests, I started to think about AI as a tool, where I think, for instance, that instead of having a request for rendering a server-side render page, instead of asking to AI, give me everything. What I really want from AI, that I like the non-deterministic approach, is the layering, or how I design the layout of my page. So if I'm capable to have a bunch of micro frontends that I design carefully in the way that I want, without any possibility to screw them up, because I will basically use them. And then I ask AI to provide me a layout. And then in server-side rendering, I take basically these microfontents I created, the layout provided by AI, and I merge them, leveraging transclusion like we were doing in edge side, includes the server-side rendering, etc. Then suddenly you can have a very high dynamic website that can be, let's say, completely personalized hand-to-end, and that is provided with an experience that is unique to either your users or to your community or your users, based on how they are consuming the website, because you are feeding back the AI with the information needed, but you have full control on how the information will look like when you're rendering it. Because yes, chats are great, but I don't know what you spend, like, I don't know, 4 hours chatting with Claude or whatever else you're using. At some point, it's okay, well, why we started that conversation, why we were saying that thing, why we ended up here. Then you start to scroll up and you don't find anything. I strongly believe, and I started to see, for instance, recently on Spotify, that I really liked, this idea that the UI should continue to have, let's say, its own capabilities with buttons and everything, but behind the scene, we are leveraging AI for generating things that are unique to the users or to the experience that you want to propose. Like if you go to Spotify now, you have a new rail with, let's say, some prompt that you can say, okay, I want to listen to music that I listened, I don't know, 5-10 years ago. And it's basically researching inside your history and generating a playlist on the fly with a bunch of information augmented by AI that makes the thing more interesting. So if I start to think about how AI will impact the UI in the future, I think there will be a massive impact if instead handing over everything to AI, we start to aggregate what we know that is deterministic to what is not deterministic, and we merge all together for having the optimal solution. And again, it's still trade-offs, but the cool thing of this approach is that you wait way less on AI, because we know that it's basically cranking some numbers, and if you operate at scale, it might be complicated. While in this case, you can potentially end up with a small language model instead of large language model, and you are going to have, let's say, a save on performance and cost on this approach, because it's generating just a tiny portion of the system that is basically a bunch of information that you need to put together, and it can evolve without you retraining models and whatever. So I think this can be a good starting point. This is what I'm researching at the moment. I think it has some legs from the test that I made at the moment.
Awesome. Cool. Yeah, this was a fantastic outlook. So big thanks, Luca, for sharing all those insights. Big thanks for being such a fantastic community member who is sharing all this stuff with us. So it's really, really a huge thing and provides a lot of value for people out there. So big thanks and see you around.
See you around, and thank you for having me.
Thank you.